Okay, in this video, I'd like to do problem 7, or at least a portion of problem 7 from the review sheet for you. And so in this problem, it says, explain using the diagram what the following access control lists accomplish. Part A gives an example. Note the diagrams only show a limited IP space of 256 IP addresses. That is the size of a Class C network. And don't forget the implicit deny at the end of every ACL. And so part A is really an example that's already solved. I'll walk you through it though. And so in the first line of the ACL, it says to permit the subnet 192.168.85.64 with a wildcard mask 0.15. And so what this means is that, well, first of all, we have to realize that this is an IP space of 256 addresses, meaning that this full width at the top here is 256 IP addresses. This is exactly the size of the last octet of the IP address. So we're going to completely ignore the 192.168.85 from here on out. We're just down in that 256 IP address space, which is represented by that last octet. And so we can do a /24 network with 256 addresses in it. And in that case, the net mask is 255, 255, 255, 0. That is 24 ones and 8 zeros, /24. If we divide that last octet up into two different subnets, we get two different /25 subnets, each with 128 addresses in it. And the net mask for a /25 has 25 ones in a row and then 7 zeros at the end. If you put a 1 at the most in the first spot of 1 byte, you get a 128. Okay? Similarly, with a /26, we have 26 ones. 128 plus 64 is 192. That's those first two bits. A /27 has 32 addresses in it. And there are 1, 2, 3, 4, 5, 6, 7, 8 /27s within a Class C. So this whole thing is a Class C. Okay, so we're essentially subnetting a Class C. Similarly, with the /28, there are 16 /28s with net masks with 28 ones in a row. 28 ones, we have 24 of them here, 4 more of them. And it turns out that 128 plus 64 plus 32 plus 16 is 240. Okay, so these are the network masks. The wildcard masks are just the opposite. Zeros and then ones rather than ones and then zeros. And so if we have 8 ones at the end, we get a 255. If we have 7 ones at the end, we get a 127. 6 ones at the end, we get a 63, and so on. And so it's nice because you can see here the correlation very clearly between the size of the subnet, 255 or 256, and the last value in the wavelength mask, 255, 128 to 127, 64 to 63, and so on. So we can look at these ACLs and tell exactly what range of IP addresses they're talking about. And so in fact, the first one here, .64, so this .64 is the IP, is the subnet ID, and so it's going to start at address number 64. How do we find that starting point? Well, we look at the 64, the H equals 6 part of this diagram, and we go out to 64 here. And we're talking about a subnet of size 16, so we go down to the H equals 4. And so we're going to start at 64 and have a chunk of width 16. And we're going to permit that one. So this is the first P1 I'll put here. That's the first line of that ACL. It starts at 64 and has width 16. The second one starts at 64 with width 32. So that's this deny here. It's a deny. It starts at 64, has a width of 32. Once you get the hang of it, it's very straightforward. Then we have a permit starting at 0 of width 256. We're going to start at 0 of width 256. So it's this one at the top. Okay? And then we're going to deny any after that. And so that permits, gives us a view of which IP addresses are permitted and which are denied by this ACL. And one thing when you look at an ACL, you always have to consider the order in which the entries are given, because we use first match logic. First match logic means that as soon as we find an IP address range that matches our IP address, we're going to go ahead and perform the action that ACL says on that IP address. In other words, we're looking at either a router or a firewall, and we have a packet coming through with a certain IP address, and we're going to try to find a match of that IP address to one of the lines in one of the ACLs applied to that interface going in that direction. And so as soon as we find a line that matches our IP address, we're going to do either the permit or the deny that line tells us, and we're going to stop evaluating from there on out. And so, for example, if we have an IP address which is within the range from 64 to 80, 64 plus 16 is 80, from 64 to 80, it's going to match on this first line, and we're going to then permit that packet. Okay? Now, if you go to line 2 with the same packet, it's also going to match because it's within that range of IP addresses that are denied. However, it's already been passed. Line 2 has no effect on that packet that matches to the first line. Similarly, anything that matches the second line is also going to match the third, because the third is a superset of the set of IP addresses that match the second line. Okay? And so you can look at this diagram and get a pretty good idea that everything is permitted except for this one little space over here that is denied. Okay? Everything is permitted except for this 16 IP address wide subnet. And so you can use these diagrams to come up with a shorthand way of seeing how to write a shorter access list. That'll be problem 8 though. So this is just an introduction to problem 7 and the idea of using a diagram like this to help you to subnet a Class C network. And you can see you should practice making this little diagram on your own, labeling it with the H value, that's the number of bits in the host address. Each H value has a corresponding slashed value for the IP address, for the IP subnet, and a corresponding net mask and wavelength wildcard mask. So, in the next video, I'll do part B of problem 7.